Hello, my name is Jessica Hausman, and I am a support scientist for NASA's Physical Oceanography Program. And today I will be speaking about open science for ocean climate scientists at NASA. So open science basically means that your data, code, and publications are open and available to anyone. There are basically no restrictions in accessing those items. This helps reduce the stovepiping and repetitive nature that can occur with science, whether it be for data wrangling or just performing basic analysis on your data to retrieve your initial science results for analysis. So basically, instead of you reinventing the wheel and everyone else reinventing the same wheel, everyone shares their wheel by sharing their code and their data. And also, the publications are freely available so that people can read about your process. This will enable more science by reducing the time needed for writing the code, and it also makes it easier to work collaboratively within not only your group, but other groups within your discipline, because now everyone's working along the same principles and guidelines of code. So now more time can be developed on the actual analysis and answering your science questions. A good example of one of the programs within the Physical Oceanography Program at NASA is ECCO, which is the Estimating the Circulation and Climate of the Ocean Data Assimilation Model. It has created several Jupyter notebooks that help scientists understand the data formats and read the data and do basic analysis to help integrate it into their science workflows. And the success of this is shown by having over 100 new publications within a year, all because ECCO has made it easier for the science community to use their outputs. The fleet of sea surface height altimeter missions are also within the Physical Oceanography Program at NASA. This has started since 1992 with Topex Poseidon and has operated continuously through the Jason series and the recently launched Sentinel-6 Michael Freilich last year in November. And Sentinel-6 is a good example of the continuing progress of open science within the Physical Oceanography Program. It has continued the tradition of not only measuring sea surface height, but the new tradition of it being the first NASA mission to be fully cloud data distributed. So with this mission and all future altimeter missions from NASA, they will all be found on the cloud. And so as you can see in this image, this is the current swaths of the operating satellites. Not only is there Sentinel-6 Michael Freilich, but also Jason 3, and then two ESA missions, Sentinel-3A and B. So you can see that there are still gaps within the orbits. So while the spatial resolution is not very high, we have a very long time series. But not for much longer, because we are adding in a new mission called SWOT, which is for Surface Water and Ocean Topography. SWOT will be on a different orbit, but not only is it going to be measuring sea surface heights, but also lake and river heights over the surface of land. And the big thing about SWOT is that its data is going to be very large because it is an interferometer SAR. And you can see in this animation of currents derived from altimeters, you can see that this is the current spatial resolution that we have now, combining all the satellites together. And when SWOT launches in 2022, this is what the expected resolution is going to be from that one mission alone. So even though we will not have a long history of SWOT data, we have very high spatial resolution. So that's why SWOT is also being put on the cloud, because the amount of time it would take for downloading and doing data analysis on that type of volume of data is going to take a very long time. And so being able to put your code next to the data will help improve the amount of time that it takes for you to do your basic analysis as you would do it now if you haven't already switched over to the cloud. Of course, just switching over your workflow into open science does take some effort. So there is the Pangeo project. It is sponsored by NASA and NSF, and it is basically trying to coordinate scientists, software, and compute infrastructure so that it can help promote science that is open, reproducible, and scalable. So these are all Earth scientists who have switched over to open science, where they share their code amongst their colleagues, and their colleagues are also developing further on that code, and also how to do compute on the cloud. So all of these members have all gone through the pains of and struggles of trying to migrate their workflows, and so this is a good place to find out exactly like when you get stuck. These people have probably been there before. And of course, all the data I spoke about is freely available from Podac, which is one of NASA's data archives specifically for physical oceanography. And they also have tutorials on how to access data on the cloud. So I hope this presentation has demonstrated to you how open science is integrated into NASA's Physical Oceanography Program. The code sharing and data sharing allows for more efficient and shareable science, which has been proven effective and doable through ECCO and other communities in the Physical Oceanography Program. I hope that you take the information from here and are able to apply this to your continuing open science adventure. Thank you.